Rework rate is an Agile metric that measures how much work needs to be redone after it was initially completed. It highlights inefficiencies in the development process by tracking tasks, user stories, or features that require corrections, fixes, or significant changes. In simple terms, it answers the question, how much of our work are we doing twice? At a high level, rework rate reflects the quality of both execution and understanding. When teams clearly understand requirements and build things correctly the first time, rework stays low. When misunderstandings, defects, or missed expectations occur, rework increases. This makes it a powerful signal of deeper issues within a team's workflow. Rework can come from many sources. Common causes include unclear requirements, poor communication between stakeholders and developers, lack of acceptance criteria, technical defects, and last-minute changes. Each of these introduces uncertainty, which often results in work needing to be revisited. In Agile environments, rework is particularly important because teams aim to deliver value quickly and iteratively. High rework slows down delivery, reduces team capacity, and disrupts sprint commitments. Instead of focusing on new value, the team spends time fixing what was already considered done. Rework rate is typically calculated as a percentage. It compares the amount of reworked effort against the total completed work within a given timeframe. For example, if a team completes 100 story points in a sprint, and 20 of those points involve rework, the rework rate is 20%. A moderate level of rework is normal and even healthy. Agile encourages feedback and adaptation, so some rework naturally occurs as teams learn and refine their solutions. However, consistently high rework is a warning sign that something is fundamentally broken in the process. One key driver of rework is poor requirement clarity. When user stories are vague or incomplete, developers may make assumptions that later turn out to be incorrect. This leads to rework when the product does not meet stakeholder expectations. Strong backlog refinement practices help reduce this risk. Another major factor is insufficient testing. If defects are not caught early through unit tests, integration tests, or reviews, they surface later in the process when fixes are more expensive and time-consuming. This increases rework and reduces overall efficiency. Team collaboration also plays a critical role. Misalignment between developers, testers, and product owners can lead to incorrect implementations. Regular communication, daily stand-ups, and shared understanding of goals help minimize these disconnects and reduce rework. Technical debt is another contributor to high rework rates. When teams take shortcuts or delay proper engineering practices, they often have to revisit and fix those areas later. Over time, this compounds and increases the overall rework burden. To reduce rework, teams can focus on improving definition of ready, strengthening acceptance criteria, increasing test coverage, and fostering better collaboration. Practices like pair programming, code reviews, and continuous integration also help catch issues early before they become costly rework. In conclusion, rework rate is a critical metric that reveals how efficiently a team delivers value. While some rework is expected in Agile, excessive rework signals problems in requirements, quality, or communication. By monitoring and addressing rework, teams can improve productivity, deliver higher quality outcomes, and build a more predictable and sustainable development process.